Let's solve this problem. They have given that a computer system implements 8 KB pages. What do they mean by this? They are saying that page size equal to 8 KB. See, I'm just writing out the data, okay, so that it will be easy to understand the problem and solve it. So in case if page size equal to 8 KB, then obviously frame size will also be equal to 8 KB, right? And also they have given that and a 32-bit physical address space. What does it mean? The size of physical address is nothing but 32 bits. The size of physical address is 32 bits. See, from this we can calculate, they have given frame size, right? If frame size, and also they have given here that it is a byte addressable system, right? Which means every byte will be given an address. Now, I can write this as 2 power 13 bytes, right? 2 power 13 bytes. Now, in order to address 2 power 13 bytes, assuming that it is a byte addressable system, we need 13 bits, right? We need 13 bits. So our page offset or frame offset, since it is physical address, our frame offset field will have 13 bits, right? This is what I can compute. Now in case if this is 32 bits and if this is 13 bits, then this is nothing but 32 minus 13, which is nothing but 19, right? This is frame number field. See, these things I can derive using these two lines, right? What we have read. That is what I'm doing it, so that it will be easy to solve the problem. Fine. They have also given that each page table entry contains a dirty bit, a present or absent bit. Okay, that is what I mean by PRA bit. A present or absent bit, 3 permission bits. See, what is meant by permission bits? It is just going to indicate whether it is a read page or write page. It is nothing but the protection information, right? We have seen it. That we can also say that as permission bits, right? It is just telling the permission whether you can read the page or write the page, or you can do both read and write or not. And the translation information. See, what do we mean by translation information? It is nothing but the frame number field which we maintain in page table entry. See, what the frame number field is doing actually in page table entry, it is actually helping us in order to translate the logical address into physical address, right? That is what we mean. The translation is actually happening from logical address to physical address using page table entry, right? In fact, it is nothing but it is done using the frame number field inside the page table entry. That is what they have given. By translation information, they mean that frame number field. Okay, so a page table entry is going to hold one dirty bit, fine. It is going to hold one present or absent bit, fine. It is going to hold 3 permission bits, right? Maybe they might have more than 4 types of permissions: read page, write page, read or write page, read, write, execute page, something like that. That is not important, but they have given that we need 3 bits in order to indicate the permission bits. Fine. Also, they have given that translation information, which they have not given, right? But we have actually computed it here. Our translation information is nothing but frame number field, right? That is what we have seen. It is going to indicate the frame number in which the corresponding page is present. Now, in order to indicate the frame number, we need 19 bits. So, this is nothing but 90. Okay, we have computed it. So, page table entry size is nothing but 19 plus 3 is 22, 22 plus 1 is 23, 23 plus 1 is 24. So 24 bits. This is very, very important. Okay, don't get confused here. It is bits, it is not bytes. If you want, you can divide it by 8 and then you can make it as bytes. Anyway, let me have it like this. Okay, in case if I want, I can simplify it. If the maximum size of the page table of a process is 24 megabytes. Okay, so what they mean by this is they are saying that page table size is equal to 24 MB. 24 into MB, I can write it as 2 power 20 bytes, right? 1 megabyte is nothing but 2 power 20 bytes. That's what I have written it here. Fine. They have also given 24 MB. The length of the logical address supported by the system is dash bits, which means they are asking what is the total length of the logical address in bits. Okay, they are asking in bits, that is important. We have seen this, right? The system is a byte addressable system. That is what we have been assuming it so far. Fine. So what we need to find here is we need to calculate logical address, right? Let us assume this is our logical address. Now let's write down what are the things we know in our logical address. See, our logical address will have one thing is page number field and it will have something called as page offset field, right? So in case if page size equal to 2 power 13 bytes and if it is a byte addressable system, then our page offset field will have 13 bits, right? This is what we can write it. Now in case if we can find out the number of bits in page number field, then what we can do is we can add both of them and that is the total length of the logical address. And that is what they have asked, right? That they are asking the length of the logical address supported by the system is dash bits, which means the logical address will be generated by CPU, right? Now the logical address generated by CPU will have how many bits? That is what they are asking. Fine. So one thing we can understand from this is we need to calculate this page number field. In case if we calculate it, the problem is done. So from this, see, they have given that page table size equal to 24 into 2 power 20 bytes, right? Now what is the formula for page table size? The total size of the page table is nothing but number of entries into size of a single entry, right? It is nothing but number of page table entries into size of a single page table entry. This is the total size of the page table. See, I don't have space, okay? So I am writing it in short. Please understand it. It is nothing but number of page table entries. This is nothing but size of a single page table entry. And they have given that this is nothing but 24 into 2 power 20 bytes, right? Now, do we know any of these things? In case if we know it, it's done, right? We can solve it. See, number of page table entries is nothing. We don't know number of page table entries, right? We don't know number of page table entries, okay? In case if you know page number field, we can calculate number of page table entries. Why? See, in case if number of page table entries equal to n, then number of pages in the process is also n. Why? Because for every page we maintain a page table entry. So number of pages will be equal to number of page table entries. Since we don't know the page number field, we don't know the number of pages. Since we don't know the number of pages, we don't know the number of page table entries. So I am writing it as it is. Number of page table entries. Now, do we know the size of a single page table entry? Yes, we have just calculated it, right? It is nothing but 24 bits. Now I can also write this as 3 bytes, right? 24 by 8 is nothing but 3. So page table entry size is 3 bytes, fine. So this is nothing but 3 bytes. This is nothing but 24 into 2 power 20 bytes. So bytes and bytes will get cancelled, fine. Now number of page table entries is nothing but 24 divided by 3 is 8, right? I can bring this 3 down. So 24 divided by 3 is 8. So it is nothing but 8 into 2 power 20 bytes, right? This 8 I can write it as 2 power 3, right? So it is nothing but 2 power 3 into 2 power 20 bytes. This I can write it as 2 power 23. See, it is not bytes, right? Sorry for this. This is not bytes. Don't get confused here. Why? Because it is actually indicating the number of page table entries, right? Number of page table entries will be either 5, 10, 20. It will not be in terms of bytes. And also I can tell you that bytes and bytes are getting cancelled, right? So the unit cannot be bytes. Now we are calculating the number of page table entries which we have computed as 2 power 23. So in case if we have 2 power 23 page table entries for a process, then the number of pages for that process is nothing but 2 power 23, right? Because for every process, number of pages will be equal to number of page table entries. So from this we can know that number of pages in our process is nothing but 2 power 23. Now in case if we have 2 power 23 pages, how many bits do we need in order to indicate the page number field? It is nothing but 23 bits, right? So we have also calculated the page number field, which is 23 bits. Now the question they have asked about logical address, right? What is the total length of the logical address in bits? So this is 13 bits, this is 23 bits, and this is what we mean by logical address. It is nothing but 23 plus 13, which is nothing but 36 bits. Okay, so the answer for this question is 36 bits.